inequalities in the past, okay? So what you would have been taught in first year was, you would have been taught something like, you would have been taught something like this. 5 is greater than 4. Or, let's say, 3 is less than 6. Now, the way to think of it is like a hungry crocodile. The crocodile always goes for the larger meal. So, if this is see the way it points, see the way the mouth is pointing towards the larger number? It wants to eat the larger number. Okay? So that means 5 is greater than 4 because the mouth points towards the 5. 3 is less than 6 because the mouth points towards 6. Minus numbers can be tricky. Give you another example. 1 is greater than minus 3. Once again, the crocodile reads that the 1 is better than a negative 3. So, everybody happy with the terms greater than? Less than, okay? Now, there's other little tricks that can happen here. A trick would be something like this. If I say 2 plus 5 is greater than 4, would everybody agree with that? 7 is greater than 4. I can do what we call a switch. Anybody care to tell me what a switch is? I can say 4 is smaller than 2 plus 5. Everybody see that? Everybody agree with it? Do you know, is that the flick around the science? Okay. Next thing. What we can try out with these is you can move any number over you want. What happens when we move over to 5? Turns into a. And is 2 still greater than minus 1? Means you did nothing wrong, right? Now, there's another little trick we can do. It's called multiplying both sides as well. It'll still work. If 5 is greater than 3, what happens when you multiply both sides by 2? Divide both sides by 2. Back to 5 is greater than 3. Can anybody summarize what you've learned here? You're allowed to do a switch movement where you just reverse around the sign. You're allowed to multiply both sides by the same amount and the inequality will still handle. If the left side starts off bigger than the right hand side, it doesn't matter if you divide both sides by a positive number. You can still say 5 is greater than 2 if you divide both sides by 2. You can multiply both sides by 5 and you can say, look, 25 is bigger than 10. So what I'm trying to say is that if the left side is bigger than the right side and you multiply or divide by any positive number, everything's still okay. The left side will still be bigger than the right hand side. Is everybody cool with that? Any questions so far? The next thing I was asked, and somebody lucky enough taught that before me, what happens when we multiply both sides by a negative number? Let's find out. 2 examples. First example would be something like this. 6 is greater than 4. So 6 is greater than 4. Multiply both sides by negative. Minus 6, minus 4. What do you think happens to the sign? Has to switch. I think what we've learned there is that if you multiply both sides by negative, you better flick around the sign at the same time. Let's try it again. Minus 1 is a bigger number than minus 5. Everybody agreed? Multiply both sides by minus. See the way we changed the sign? Yes?
So is it every time you multiply?
There's 2 ways of doing the same questions, okay? So, what we have here is a bog standard inequality, question 2. 5x minus 7 greater than 3. X element n means natural numbers only. 5x is greater than minus 7. Now, the minus 7 goes over to your side, so it ends up to be 5x greater than, turns to a plus 7, 10. Divide both sides by 5. X is greater than 2. What natural numbers are greater than 2? Can I include 2? Can I include fractions and decimals? Why am I not allowed to include fractions and decimals? Yes. Natural numbers. So the first number I can think of is 3, 4, 5, 6, and then it continues on forever. This little arrow indicates that I'm going to go on forever. Does that make sense? Now let's try another one out. Look at question 4. 2 and 4, yeah? Now look at question 4. 7x plus 1 less than or equal to 3x minus 15. X element R. Fractions and decimals are allowed. Negative numbers, allowed. Bring the 3x over to the 7x and it becomes 7x minus 3x. Bring the minus 15 and minus 1. 4x less than or equal to x less than or equal to. Divide both sides by 4. Minus 4. Minus 4. Is that allowed?
Yeah.
It is, because it says equal to as well. See the equal sign? Is fractions and decimals allowed?
Yeah.
Then you do a shaded in line, because you want all the fractions and decimals. How long is this going to go on for? So you best put yourself an arrow down. Okay? So that's 2 and 4 done. With 2 minutes remaining. Should be able to get another 1 or 2 done. Now, oh dear. Look at this one here. You think it's a bit harder? We'll try question 12. 12 is element Z. You got it? So what do you think about element Z? Just going to multiply it out quickly. Everybody see all I'm doing is standard maths, yeah? Nothing fancy. Now there's a trick in here that I'm going to show you. That's 9 minus 1. 8. 9x take away 10x greater than or equal to. Bring the 8 over to your side. Now here's the trick I'm going to use. There's a trick in here. Minus 1x greater than or equal to 4. I do not like minus 1x whatsoever. Neither will you. Multiply both sides by minus 1. What happens when you multiply both sides by negative? Sign switch. This essentially means x is smaller than minus 4. Is minus 4 included? Because of the equal sign. Are decimals and fractions included?
Yeah.
No, why not? Has to be whole numbers. So I'm only allowed these numbers here. And you're done. Okay guys. For homework tonight, the evens there. 2, 4, 6, 8, 10, 12.